application engineers with Reynolds Machinery, and we're here in our showroom at our West Carrollton location, and we're going to take a quick 5-minute dive into why 5-axis.
Yep. So why 5-axis? What are some reasons why I'd want to purchase a 5-axis machine? I've got a bunch of 3-axis machines. We have no problems running those. Why do I need a 5-axis machine?
For me, it's, multiple setups. Again, as we mentioned earlier, like we take a part like this that requires multiple setups and holes on angles, pockets and sides, just accessibility, where I can't normally get to it in a traditional 3-axis machine.
Right.
So for me, reducing setups. But a big benefit of that is by reducing setups, we can quickly react to our customers' needs. Because you take a part like this, now, I go through the quoting process and I'm gonna have to build a fixture to hold a part on the angle. I'm gonna have to have multiple setups.
Mm-hmm.
So being able to react to customer needs quickly, is a big key too for me.
Yeah, one thing that goes hand in hand with that, I think, is accuracy. So, like you mentioned, taking this part from setup to fixture to ops, a part like this could have 10 different setups in it.
Correct.
Well, now if I'm going on a 5-axis, I can get the majority of that out of there and have a lot more accurate part. I'm not scrapping out parts, going through setups, going back and forth with inspection. That's all staying in the machine. I'm hitting as much of the part I can in one setup. And keep in mind, most 5-axis parts, we can do them in 2 setups. We can do an op 10, raw material, hit all of this, and then maybe for a part like this, you would need a fixture to flip it over and do op 20.
Correct.
So accuracy is a big selling point that we see a lot of our customers going to with 5-axis.
How about another one for me is times have changed.
Yeah, absolutely.
I've been here at Reynolds 16 years, and if you go back then, cam packages were just so expensive. It was really difficult to cross that bridge from 3-axis into 5-axis.
Yep.
Now you got cam packages like Fusion, on control capabilities of doing 3+2 machine and surfacing. So that helps combat, that fear of moving to 5-axis for me.
Yeah, that's a great point, and I agree. When I started in the industry, 15, 16 years ago, cam packages were way out of the budgets of a lot of shops, and now with the evolution of things, things have changed.
And the control technology.
And one thing too, moving to a 5-axis machine, look at the other capabilities that I'm going to have with that machine. Now that I can do simultaneous work, something like this, if that were to ever come down the road, I have the machine capability to do that now.
Yeah, you're expanding your capabilities.
Where maybe in the past, if something like that, or even something like this came up, maybe I'd have to no quote that.
No quote it. Yeah,
so
exactly.
At least now I can throw my hat into the ring. So Aaron, there's multiple configurations out there for 5-axis machines. So let's take a few minutes and just talk about a few types and what one might be better over the other and vice versa.
Okay, I gotcha. So for me, the way I break it down is there's multiple configurations. A table, that's where both rotary axis are built into the table. You got a head table, like this traditional swivel head with a rotary axis here.
Yep.
And a head configuration, where both the tilting axis and rotating axis are built in the head.
Yep.
What do you think your favorite configuration is?
For me, it really depends on the application. I like them both. The swivel heads, I think, are a little more adaptable to different size parts.
Right.
I can run a small part on there, and then at the same time, I got a full, size T-slot table. I can put a bigger part on there.
Yeah.
Run it more like a 3-axis machine. But if I'm doing more, I got 5-axis parts all the time. Maybe a trunnion machine, because those are a little more specific to the size of the part rather than just, how big of a part I can.
So you would say like a trunnion machine, size matters. That you want to size your part to the table that it's going on.
Correct.
Right?
Yeah.
Okay.
Right.
And where, yeah, I see your point. Like, you know, the swivel heads, I do like that feature of them because, you know, I can run a small part like this. You know, I could run a larger part, and I do have, you know, that full table, traditional T-slot table where I can run traditional three-axis work.
Absolutely. And one thing too, just through the years, I think the trunnion machines are popular, the swivel heads are popular, but I think when you're new to 5-axis and you've never run one before, the trunnion is maybe a little easier to grasp your head around because it's still a traditional, you know, C-frame 3-axis style machine with a tilt rotary in its place.
So that's a good point. I would say that trunnion machines are probably more cost effective, right?
Yeah.
Yeah, because you know, you take into a swivel head, a rotating head, it's probably a motorized spindle.
Right.
You know, it's going to obviously cost more money.
They're a little more high performance, the swivel head machines.
Right. What do you think about like programming? Like, is there one easier than the other? Or do you think CAM packages have made it easy and control technologies?
I think between the control technology and the CAM packages, you know, they've made it really easy. I can just click on my control or click on my CAM package, and you know, my code's going to be outputted to that style of machine.
Right. Especially, you know, for me too, you know, since like Perco, they have like vector style input programming. You know, the same program works on, you know, any configuration of machine.
Absolutely.
Which is nice because that goes in, you know, back to, you know, control technologies and
right.
times have changed.
Right. So again, with the style of machine configurations, you know, trunnion machines and swivel heads, you know, at the same time, can they vary, like maybe performance-wise? Like maybe some have slower rotaries and some have faster rotaries on them. What do you think about that?
Yeah, that's a good point because I don't think it really matters a lot if you're doing like traditional like 3+2 work. You know, obviously a 25 RPM table versus a 100 RPM table is faster.
Right.
But I think that, you know, it is important when you get into simultaneous machining.
Absolutely.
If you're doing that.
Yeah.
You know, if that's the type of work you're doing, because, you know, the faster rotaries, that's going to be your limitation,
right?
You know, as far as feeds and speeds boils back down to the limitations of the speed of your rotary tables.
Yeah, absolutely. I could see where, like on this part, if I was doing a lot of simultaneous, you know, I'd want a really fast rotary. But, you know, something like this where I'm just indexing around, you know, right. I don't need that speed because it's still
100 RPM table.
Yeah, absolutely.
Let's talk about 5-axis work holding.
Okay.
So obviously we know there's all kinds out there, right? All different brands, all different types. Let's talk about self-centering vise. You know, why do you think that's important? Why do you see people utilizing self-centering vices on 5-axis machines?
Yeah, so like you mentioned, you know, there's so many options out there for work holding in general. And when we get to a 5-axis machine, we don't just want to take our vise that's been on our 3-axis machine and then set that onto our 5-axis machine. You know, on a traditional style vise, you know, the vise body is very big, right?
Right.
Well, on a self-centering vise like this one here, the jaws move in and out together, and the vices are a lot more streamlined. Right. So I can put my material in here, and a lot of these self-centering vices too, regardless of the brand, actually have teeth right here that bite into the material.
Yeah, that's a good point.
So, you know, I can put a big block in here, you know, this tall, for example, on something like this, and these teeth are going to bite into that material and hold on to it.
How about accessibility because of self-centering?
Yeah, absolutely.
Equal access.
You know, because it's a small configuration on the vise body, I can get around the part pretty easily compared to like a standard 6-inch, you know, angle lock traditional vise.
Right.
And the key with 5-axis is, you know, getting around the part so I can hit all those operations.
Yeah, good point.
So that's why we love self-centering vices if I want to put a vise on the machine, because we have a lot of other options that we
What do you think the downfall is, though?
You know, some of the downfall with this type of vise, you know, obviously I can't hold on to it as tight as I can with an angle lock. You know, I'm not going to put, you know, my breaker bar on this thing and crunch it down.
Yeah, so somewhat you lose a little bit of rigidity.
Yeah, but you're gaining accessibility to the part, which you're going to make up for.
Right.
When you lose just that little bit of rigidity.
Because I've noticed that they aren't quite as rigid as a traditional angle lock device, but I have the accessibility.
Absolutely.
What about dovetail vices?
Dovetails are another great option that we use. When we do dovetail, maybe we're looking at a part like this where maybe even this vise is too big to get around with my end mill. Mm-hmm. So over here on a dovetail vise, I machine a dovetail on the bottom of this part, and look how it's pretty much flush with the work holding. So I can get really tight in there with a nice short end mill or a short tool holder, where maybe over here I got to run something a lot longer.
Right. So even better accessibility.
Right. Now, what would you say a downside is with a dovetail type work holding?
I guess for me, it's just machining the dovetail. Right?
Absolutely. It's another op you got to throw in there. But again, kind of like with this, you lose a little bit of rigidity, but you're gaining accessibility. So you could look at that the same way here. I'm machining that, I got to prep that, but you might have to do that if you want to do a part like this in 1 op or 2 ops.
But for me too, like the dovetail vise, the rigidity, you're getting it. It's quite a bit of difference from a traditional to self-centering vise.
Absolutely.
What about direct mounting fixtures?
Yeah, that's another good one too. We use a lot of direct mounting. Could be, maybe I just bolt the material right to the machine. There's a lot of options out there where, even on something like this, they have direct mounting where I can put more of like a retention knob style.
Correct.
On the bottom of my vise. Or I can machine my block and put that retention knob right in the material.
And they essentially just have pucks that you mount them on,
Absolutely.
right? Which
Absolutely.
allow for flexibility for small or larger parts.
Yeah.
You can use like 1 puck, 2 pucks,
right,
and just accessibility.
Right. Well, Aaron, we took a quick dive into a few topics. What makes a good 5-axis part, the types of configurations of 5-axis machines, and then some work holding. But there's still a lot more, right?
Yeah, we just scratched the surface. And feel free to reach out and let our experts look at your application. And be sure to join us next month as we take a quick dive into turning centers, Y-axis, and subspindles.